Officer of Twilight MedTech Private Limited, and currently involved in startup mentoring activities. Meanwhile, he was a project scientist at Nanoscope Technologies for a brief period of time. He was featured in Facebook's special coverage, The Limitless, as one of the India's leading innovators and entrepreneurs of 2018. He has more than 55 publications, which include patent, books, journals, and proceedings. His findings on AI-based retinal disease detection and AI-based early-stage cancer detection has been highlighted in all leading newspapers like the Hindus, the Economic Times, the Indian Express, Business Standard, Daily World, as well as on television channels like G News, Odisha TV, NewsX, News World India. His research success also has been featured in leading national and international tech magazines like eHealth, Analytics India magazine, The Better India, Biospectrum. He received several international awards, which includes Best Research Paper Award, prestigious SPIE Photonics Education Scholarship 2014, most Inspiring Facebook Developer Circle Heat, and Alumni Award 2020 by IISER Kolkata, and so on. He delivered invited talks, served as panelist and judge in leading IITs, IISERs, NITs, IIEST Shibpur, and many leading state, central universities of India. He also delivered invited talks in foreign universities like University of Global Village, Bangladesh, University of Anand in Guinea, and so on. So Bushaki's research on AI-based early-stage cancer detection has been included in current affairs syllabus of India's top government official competitive exams like UPSC, IAS, IBPS, banking. His TEDx talk was featured in news channels including ETV, Telangana, Chappudu TV, and the newspapers like Velugu, Andhra, Jyoti, Sakshi. He also wrote technical articles for the editorials of leading Bengali daily Anandabazar Potrika. His, he received honorary mentions in government official site of Embassy of India to Switzerland, the Holy See, and Liechtenstein for his research. Now I will request Shubhashachi to start the session.
Thank you, ma'am, for your generous introduction, and I am completely privileged to be invited by CM Kolaghat at this esteemed faculty development program. So basically, actually, I am uploading the presentation. There are some technical problems. It is taking time. So kindly hold on for a few minutes. It will be uploaded soon. I hope so. Okay, so finally it is showing there. So good afternoon, everyone. Today our topic is about exploring AI in healthcare. So myself, Sabyasachi Mukhopadhyay. I am the Kolkata lead of Facebook Developer Circle. I also involved with Google as a Google developer expert in machine learning. I am the Intel software innovator as well. Apart from my industrial exposure, I am also close related with academics, currently involved with SCIT Pune as a visiting faculty of analytics in PG Management Studies, as well as at BIMS Kolkata. Playing the role of teaching their analytics as a part of the PG management studies. So let's start with our today's topic. So what problem should we solve? First of all, you see the development of the science technology, whatever has happened, which has created impact in our current society. So there are certain paths. First of all, what is our thought process regarding that? So philosophy plays a pivotal role there. So philosophy followed by science, followed by technology, followed by product, and followed by market. So this is the way you can actually generate a proper scientific contribution which can create impact on the bottom of pyramid. So what is bottom of pyramid or BOP? Across the globe, there are more than 80% people under the bottom of pyramid category, and India the percentage is 96%. So you can understand the scenario. If somebody is suffering from cancer, somebody is suffering from diabetes retinopathy, how miserable will be their life to bear those expensive treatments. So whatever may be our profession, maybe a scientist, maybe a professor, maybe a academician playing any kind of other roles, but if we can contribute intellectually through deploying, for example, here we are talking about AI, it may be some IoT based approach, it may be some photonics based approach to contribute or to develop certain low cost solution which can create impact in the affordable healthcare domain. That would be nothing better can be that. So that's why, we will gradually discuss that how we can spot out a problem. So as far you know that there are two potential areas we can currently concentrate on, and there are a lot of initiatives has been taken by the government of India in terms of the healthcare domain as well as the agricultural domain. So we have chosen the healthcare domain where we can actually create impact on the billions of lives. So how we have proceeded, that would be the major matter of the discussions. So what is the problem or solving? So how will you proceed? So first of all, we'll see the resource map. So under the resource map, people, organizations, user beneficiaries, breakthroughs and risk factors, then gradually problem canvas, solution canvas, and finding plots. So let's discuss one by one. So first of all, under resource map, we shall discuss people and organizations, user and beneficiaries, breakthroughs and risks. So if, for example, if we talk about the healthcare domain, so who will be the potential contributors? So basically the organizations will be the healthcare sector, hospitals, nursing homes, medical clinics. Okay, so definitely other companies can also join as a major stakeholder, other startups, even the different government agencies can be a good partner. Data sets and information resources, definitely data sets are obviously online available. There are a few data sets, for example, in Kaggle or GitHub, you can download them and you can deploy your algorithms. Or otherwise, to build a real world strong applications, you have to collaborate with different hospitals by tying up with them through different protocols. For example, there are available protocols like IRB protocols, which we'll gradually discuss. So in this way, we can get the proper adequate data sets. Okay, then partners. So who can be the other partners? So academicians play a pivotal role. There are several good number of institutes in India and across the globe which you can collaborate. Definitely other research institutes, for example, LV Prasad Eye Institute. This is they are also very actively involved. They are the academic partners, people, VCs, and influentials. So who are the potential influencers here? So definitely the eminent doctors, eminent physicians, who plays the pivotal role in case of the approving different medical products. Obviously the seed funding you can take from government, you can take from any other private agencies. So 25 lakh to 50 lakh range in Indian currency is the seed funding range. But VCs also, for example, 5 crore to 10 crore this is the range in the terms of the crores in Indian currency whenever your prototype is successful. So there are several influential VCs in India as well as in abroad, for example in Silicon Valley in US. They can also give the potential contributions and known published challenges. So there are a lot of exciting healthcare challenges are available in the website of United Nations. GET foundations, National Science Foundations, National Informatics Health, DBT, Department of Biological DBT, and Department of Science and Technology, DST. So these are the resources you can utilize to spot out a proper problem and proper resource mapping. Next, user and beneficiaries. So once we have done the resource mapping, next thing will be the definitely who are your potential customers, who can be your potential customers if you develop a product through your research work. So basically the graph of users, definitely there will be the hospitals, there will be the nursing homes, doctors who will be available in that particular case, influencers, as I mentioned, that the physicians play significant role as a term of the influenciers, buyers and sponsors. So different medical shops can be a good buyers. Definitely, we will get the sponsorship from the different government agencies who are currently playing a significant role to provide the low cost solutions in the chronic on the domain of the chronic diseases. So it can be cancer, it can be diabetic retinopathy, which is the vision loss, and nowadays we all are suffering from the pandemic like COVID-19. Partners we already have discussed. What do we now? Also, we need to check out that in which area we require to do the research. So that is also an important domain, that which area we need to focus. So that particular things will be discussed in this area. Okay, so you have to discuss with your team that, okay, this sort of the development we have made. So from that stage, we can make the further extension of our current research. And obviously, speaking with experts can be as a data scientist, experts can be your project manager, expert can be from any other doctors from any other hospitals. So it depends on the case-to-case basis. Breakthroughs, benefits, and risks. So whenever you are starting a new research project, so there are a lot of chances. Either you can get a lot of, potential breakthrough. There will be chances of definitely creating impact on bottom of pyramid, as I discussed during the initiation of my talk. And obviously there are chances of getting failure. So we have to check out that what kind of the possible breakthroughs can be there. So if we can get the breakthrough, what will be the benefit? It can create impact in terms of the low cost solutions on the bottom of pyramid level, so such that people from the lower middle class, they can bear those costly treatment with high precisions. Parallel tech, like we all talk about the cloud computing. So basically whatever the AI based solutions we develop, so the storage and analytics are done in the cloud. But due to the latency in cloud nowadays, to reduce the latency and to get the real-time output, people are also taking some parallel approaches like edge computing, fog computing. Okay, these things are emerging gradually. For example, mobile AI-based mobile phone solutions, one of the good examples of the edge computing as well. So payoff, results, benefit, in fact, we already has covered. So we have to take care of the backup plans if our algorithm fails, if any other subsidiaries which we are taking help in terms of the research progress, if that fails. So what will be the backup plan such that we can overcome that particular scenario? And remember that whenever we are starting a project, we will have a certain sort of funding, and we will have certain sort of deadline. It may be a deadline of 2 to 3 years. We have to wrap up the project within that deadline, and definitely we have to report government or any other agencies wherever we are taking the funding. So there should be a backup plan, that if plan X is not working, such that we can go for the Y planning, the plan Y. The frictions, regulation, bias, etc. This is the very important factor, because whenever you are starting a new project, you have to have about the government rules, regulations, and what that they considered can be as a frictions. So for example, whenever you are using the patient data, by ethics and rules, you can't reveal their names. Okay, for example, if in any other ethical issues, like if you are using certain tools and methodologies to develop certain algorithms, so whenever you are tying up with hospitals, the tools, the instruments you are following, that should be completely non-invasive to human tissues, and you have to provide the declarations whenever you are meeting the tie-up. So you can see in our case, we have used the white light spectroscopy, which is completely non-invasive to human body. So the wavelength range will be 400 to 700 nanometer, which we'll discuss in a due course. So financial risk, definitely lack of funding sometimes can stop your project. So these are the risks, because in healthcare projects are quite expensive, and you require adequate funding to make further progress and to make a potential contribution on our society. Execution risks, limiting factors, as I told, that the time frames were there with the provided budget. So can you implement those things within under time? So resource mapping is required, very important thing, because with the resource mapping, it's not only about to onboard the experts on your team, but as well as you have to distribute the work on a skill matrix matching basis across the globe. Any top organization, whether it is MIT, Harvard, or Stanford University, or whether it is Google or Facebook, everybody works in a skill matrix matching basis. So for example, a people named X is very strong in analytics, people named Y is very strong in Android app development, people named people named Z is very, very strong in marketing. So these three people will come together and build a team, and there will be a project supervisor over them who will take care of the project outcomes on a timely basis. So this is called skill matrix matching, the technical term. So in this way, you can overcome the challenges, the frictions you face while executing certain projects. So problem canvas. So this is very, very important. So this is I have made this particular sheet on the basis of deploying AI in agriculture domain. So what if we can map the same problem if in the healthcare domain? You see, sensors are always important in terms of the data aggregation, because these are the resources of the data collections. AI, our analytical tool, crowdsourcing is a good way of the data collections from, and these are very, very potential solutions. And now the problems. For example, if we AI in agriculture domain, if we deploy them, there are potential problems like greenhouses, crop predictions, farmer finances, weather stations. So what will be the case if I map the same problem into the healthcare? So first of all, for example, you consider that we are solving a problem like AI-based early stage cancer diagnosis. So what will be the case? So for early stage cancer diagnosis, uh, you know that biopsy is now considered as a gold standard. So what is the accuracy level of the biopsy? Unfortunately, the accuracy level of the biopsy is 65 to 70%, and it has I mean, it is not even I mean, not, for example, people from the lower financial background, lower income background, a lot of people sometimes are not being capable of to afford it. So the problems are like one can be the financial factor is one of the problem. Second is one is the your accuracy level. Okay, and the third one is the uh, uh, I mean lower reach towards the bottom of pyramid. So these are the possible problems. So can we overcome these particular problems with the solution canvas mapping? So that's with, okay, so it is buffering now. In my case, that is connected with the internet. So the screen will appear soon. It is buffering now. So in the next slide, you will see there is a solution canvas. So in what dimension we can provide the solutions. So for example, we have talked about there are problems with the accuracy level. There are problem with the treatment cost. Okay, so the major motto, what the government of India and across the globe, the governments are thinking about that, the different governments, that how we can provide a low cost solutions to bring the affordable healthcare towards the bottom of pyramid section. So if AI based any kind of smartphone based solutions we can develop. Okay, so what will happen? It can create it can enhance the accuracy level. You can achieve a 90 to 95% accuracy by deploying AI. It can generate report within 5 minutes or within 2 minutes, where biopsy takes several week times, at least 2 weeks time to come up with the report. And obviously, these healthcare based solutions, AI based solution will be the low cost one, because you see in the, for example, you have in 2016 MIT come up with a motto that softwares are the new hardwares. So what does it imply? But because if you can replace the hardwares with your software system, software based approach, it can reduce the expenses of your product development in some sort of way. So this kind of the software based approach can make the reductions in the generation. So this is the way you can actually create impact in the low cost solutions. Oh, so it is still buffering. So hello Hiroxa, should I stop here and again upload the presentation? It is still buffering. It is not appearing in the screen is not appearing.
Yes,
So
it
what
will.
I'm doing, I'm
Yes, it will guide.
okay, I'm okay. Okay, great. So it has finally appeared. So I am going to the slides where we have left earlier. So now solution canvas. For example, you can see in the solution canvas, we have discussed about the solutions in terms of AI in AI in digital, agriculture domain. So you see the constraints are cost, time, and impact. Okay, you will be provided a certain sort of budget. Okay, and with along with that particular budget, you have to provide the optimal solutions, provided that this particular solutions is impactful. So there are the scenarios. So if we can map the same thing for the AI in healthcare domain, so what will be the approaches? For example, as I mentioned, that it will be the low cost affordable healthcare domain. So for example, higher accuracy. Okay, okay. The bottom up approachable for the bottom of pyramid people. Okay, and generate report within few minutes. So in this way, you have to design the scenarios that the scenarios you want to match up with your solutions. So this will be a proper planning. That's, look, I have a certain sort of budget, this amount of the budget. Okay, so I have 2 to 3 years to make to implementation of this particular project. Okay, and in this way, I can create impact. These are the scenarios. These are the time constraint. Okay, these are the budget constraint, and under these circumstances, can you create impact on the domain in a proper manner, impactful manner? So this is the solution canvas. So now the gradually the picture will be clear to you and your team that we are proceeding, or our thought process is correct or not. So whatever may be your maybe novel intention you may imply on, but if your thought process is not clear, it will not be possible to deliver the project in a successful manner. So that's why philosophy, every time, whenever a lot of the discoveries, whatever the scientific discoveries has been made till the so far, the philosophical aspect is the prime thing. So next thing what we will see, this is the finding plot. You see, now every picture is clear. Do you know the problem canvas? You have done the mapping towards the solution canvas of those particular problems. So you can time and cost, provided time and cost, you can map down those factors in a graphical manner. Look, we are touching this particular domain, we are providing this amount of the solutions. We are, okay, this A, B, C, D, whatever the point we have decided so far. What are the current market barriers we are overcoming? What are the challenges in terms of the technologies we are overcoming? Okay, we are touching this scientific impactful solutions. Okay, we are doing that. So in this way, the whole picture, whatever the project you want to solve, is becoming clear to you and your team. So that is one of the important factors. So if you want to create impact on the billions of lives, so these are the background work is always very important and very impactful. So milestones. So basically map of users, resource requirement, dependencies, risks and workarounds, steps and decision points. So we know that what are the potential users: doctors, hospitals, nursing homes, medical clinics, patients. They will use it. Okay, resource requirements. So we know that we have to onboard data scientists, we have to onboard Android app developers. We may have to take the help from the photonics people. We may have to take people help from the biomedical engineering domain people. So these are the resource requirements apart from the grant requirements. So either you can approach to private agencies or government agencies. Okay, dependencies. So dependencies means what you have to outsource. Okay, so you may have to collaborate some other institute for the data collection purpose. You may have to tie up with different hospitals and doctors for their input purpose, because in medical domain, remember that doctors are the ultimate decision makers. Okay, because the product, when they will pass the alpha testing and beta testing phase of the product, the doctors or the physicians, they are the ultimate decision makers that whether your product is correct or not. AI is nothing but a catalyst. Okay, catalyst in terms of the to give you the high precision result, and as well as in the also playing a pivotal role in the cost reduction term. So that's why I mentioned the term, which has been mentioned by MIT in 2016-17 era, that softwares are the new hardwares. So why we should focus more on the software research to reduce the to reduce the production cost. Especially this is a quite effective way in the third world countries when we have so much financial crunch and financial restrictions. So risks and workarounds. So we have to map the risks, jot down the risk factors. For example, what can be what will happen if your algorithm fails? What may happen that if the plan A does not work? So workaround means you have to work on the backup plans, that how you can actually think of the backup plans and proceed further. So so according to that, next steps will be assigned and defined, and the decision, you have to make the decisions according to that. Okay. Oh, it is again buffering. So I am again re-uploading it. Let's see. So there are a few network issues that are going on, I think, and that's why the presentation is repeatedly buffering. So it is creating interruptions while presentation. So I am re-uploading it again. Let's hope this works this time.
I think once you can close the PPT, then you can reopen it.
That's what I have done
That
so
can
far.
be a solution. I think that can be a
I,
solution.
I have closed that one, earlier one, and then I am uploading it again. So it is showing that it is uploading, but it is taking some time. So let me re-upload it again. Let's see whether. Okay, so finally it has appeared.
Yes, now it's working.
Ah. So we will see what are the guidelines provided by the Helmer, who is one of the most celebrated inventors across the globe and belongs to Princeton University. And he is the pioneer. Most of you are from the engineering background, may be aware that the liquid crystal display LCD was invented by him, Helmer. So he's one of the one of the most celebrated inventor across the globe. The people worships, people from the science background worship Einstein. In a similar way, people from the engineering technology background salute to this amazing inventor. So he has highlighted few questions for the inventors, that if you want to get success in your research career, provided conditions that you are coming up with real world solutions which can create impact on the billions of lives. So you have to ask these 9 questions to yourselves and your team. First one, what are you trying to do, and articulate objectives without using jargon. Until or unless you can remove the jargon from your thought process, that means you are obscure about what are the aims and goals of your project. Second one is how is it done today. What are the limits of current practice, because this is a common thing, because you when you have to develop certain areas which have not been worked by others so far, so that's why you have to know the current developments. Third one, what's new in your approach, why do you think it will be successful. So what are the new path you are choosing, and how are you so much sure that this particular path is going to give you the success. Who cares? Definitely, who will be the potential stakeholders there. If you are successful, what difference will it make? Like I talked about the bottom of pyramid section. So in this way, you can think about in your own project. What are the risks and payoffs? Definitely, the risk mapping is one of the factors, that if your project fails, so what will be the possible factors which is going to give you the success? How much will it cost? So definitely the financial factor you have to take care of. How long will it take, 2 years or 3 years? What will be the project length? And then what are the midterm and final exams to check for the success? In the case of the product, if you come up with nowadays, there are the alpha testing, beta testing phases are there. And if you are deploying it for the healthcare domain, so doctors are going to make the final decisions. So these are the guidelines. Okay, so our philosophical part is completed. Now we will jump towards the science. Okay, so this is the lean canvas, whatever we have discussed so far. Problem domain, solution domain. We have talked about key matrices. We have talked about the channels. This is the go-to customer strategy. How can you can approach your stakeholders through your products, customer segment section, unfair advantages. One thing, cost structure, revenue streams, we will gradually discuss in the product section, and unique value proposition we will also discuss in the product section. So let's dive in towards science. So in medical domain, in medical technology, we generally take two kind of approaches. One is through imaging. Okay, the computer vision scientist across the globe, they took the help of the imaging, or otherwise another approach is the spectroscopic approach. So people across the globe who are in the physics background, they mostly focus, or engineering background, they mostly focus on the elastic scattering spectroscopy. Why? Because elastic scattering spectroscopy has the information of the morphological changes which happen due to the progress of the diseases. Okay, so morphological information like shape and size, refractive index, intercellular organelles, etc. Micro-optical property like fractal parameter, disorder strength, you can use it as a feature extraction purpose. Okay, these parameters. Inelastic scattering spectroscopy is also a very prominent approach in people who are in the chemistry or biochemistry domain. Those people basically check the presence of the foreign particles with the help of the fluorescence and Raman spectroscopy. So they basically measure the biochemical informations. But in our case, as we are as being the people from the engineering and physics background, I wholeheartedly follow the elastic scattering spectroscopy approach. So Light scattering based in inverse analysis models, quantification of the sub-diffraction changes in tissue refractive index fluctuation. What does it imply? So when disease progresses in our human body, so there is a submicron level changes in the medium refractive index fluctuations due to broken collagen fibers. Okay, and that can be pointed out towards the fractal based approach. Okay, because you see, whenever you are doing the data analysis, you have to choose such a intuitive feature extraction tool which actually can justify the analytical behavior. So in 2006, although this paper was not related to hardcore machine learning, but this is the very important paper in terms of the biomedical domain. If you can consider biophotonics or biomedical engineering, this PRL paper has introduced first time fractality in healthcare domain in 2006, which is the motivation behind us to explore further in this particular domain, because our biological tissues have the self-similar structure, what we call fractals. Okay, like I have mentioned here, the spatial distribution of the refractive index in biological tissue observe this self-affinity or self-similarity. Okay, and this can be analyzed through fractal Braun approximation. Now, what is Braun approximation? What is the essence of it? So basically, people who are working, who are from the electrical engineering background or electronics communication engineering background, and who have explored in the microwave domain, they are quite aware that basically when we shine the light, okay, so light hits the target, the some sort of the light will be absorbed by the target and some sort of will be backscattered. Okay, and we will capture that backscatter or the reflected backlight through our spectrometer. Okay, so the Braun approximation suggested that instead of looking on the total field, just concentrate on the incident field. Okay, this incident field will give you the information about the prominent scattering zones. Okay, so this prominent scattering zones. Now, if for example, if somebody has a skin cancer or oral cancer, if you shine the light in the infected lesions, so what will happen? Your protein lipid part of the body will absorb the some portion of the light, and few portion of the light will be backscattered. So you will capture that information. So that your information will be wavelength versus intensity. So if you use the white light spectroscopy, so it will be 400 to 700 nanometer range of wavelength. So within that particular wavelength range, you will capture the corresponding intensity, and then you will analyze the data. So basically, so what will be the approach? Because monofractal may not be realistic for the biomedical tissues having wide range of the dimensions, because you remember that we have to take the small scales and have to check the local behavior. Okay, so due to these reasons, the multi-scaling exponent and multi-resolution analysis is one of the effective ways to make the potential contribution here. So, okay, so the equation has overlapped with the document somehow. So basically, the fractal, self-similar, and multifractal. So fractal, self-similar, or self-similarity process, or the geometry. This is basically a repeating pattern. Self-similarity means the repeative pattern in your tissue structure. Okay, so fractal dimension implies that it will measure the space filling capacity. Now, basically, it gives you the power law behavior. So P of nu, if the mu you consider as your spatial frequency to mu to the power gamma. So this gamma factor, what is this? The gamma value. This gamma value is nothing but 2h plus d. The equation has overlapped with the original text body. So here d is the Euclidean dimension, and the Hertz exponent is the measure of the self-similarity. So the value lies between 0 to 1, because self-similarity means it will do the measurement of the correlation. So obviously, from our common sense, it will lie between the 0 and 1. And the fractal dimension, the formula of computing fractal dimension is d minus h plus 1. So look, this particular slide is very important slide, because you see there are very few prominent concepts of our engineering is there. So first of all, most of you are aware about the convolution theorem, right? So what does convolution theorem implies? Convolution theorem states there are two categories of convolution theorem: time convolution and frequency convolution. So in the time convolution, you come to know that if two signals are the convoluted format in the spatial domain or time domain, it will be a multiplicative format in the frequency domain, right? So we all know that in our real world scenario, that noises are omnipresence, you see. So in the terms of the engineering, we know that noise means unwanted signals, interference of the unwanted signals which contaminate the original signal. So for example, if you have a handheld devices like mobile phone, and you want to make the on live data, in vivo database classifications or judgment on whether this particular patient has a cancer or not. So what will happen? There will be interference of the stray lights with the original light, which will contaminate the original signal, your backscatter spectra. Okay, so first of all, you have to do the Fourier pre-processing. Because what will happen in the spatial domain, you know that when the signal is contaminated with noise in a convoluted format, it's very difficult to remove them. So if you convert in the frequency domain, so it will become in the multiplicative format, so you can easily remove them. This is the first point. And then the second point is that the people from the computer science and information technology background, they are quite aware that whenever we process, for example, I have n by n images. Okay, now I want to write a code, so we go for the nested for loop. Okay, for I equals to 1 to n, for j equals to 1 to n. Now what does it do? It basically enhances your complexity of the algorithm, order of n square in that case. So what will happen if we can unfold them? Remember that nowadays we talk about Ian LeCun and a lot of foreign scientists, but remember that even in the 1940s and 1950s, our Indian scientists are very much capable of doing this kind of stuffs. They have not given the name like deep learning, they have not given the name like reinforcement learning, so we don't consider them as the godfather, but they are aware of the tricks of like unfolding in the linear algebra, which is the one of the most prime zone of the AI. That we know that we call it vectorization. We unfold it. For example, in the first row you have ABC. In the second row you have the elements like DEF. What if we can concatenate these two rows in a horizontally or vertically? So what will happen? It will become ABCDEF. So now your order of complexity reduces from order of n squared to order of n. So AI is not about predicting the accuracy, but to deal with the time complexity as well. So once you can reduce the time complexity, so nowadays we are talking about edge computing, fog computing, it will be very, very helpful because for example, if you're using mobile device for the computational purpose, you will not have the same processor power support what we get in case of the desktop. So you have to use this kind of tricky algorithms to unfold the image. So you have 2D image, so we are unfolding the 2D image in a 1D signal kind of things. So then we are doing the Fourier pre-processing, and the Fourier pre-processing, we can see there are multiple power law behaviors. Okay, there are multiple power law behaviors. So that may be the significance. From the earlier slide, we have seen that monofractal can't have the multiple power law behaviors. So only multifractal can have that. So is there any multifractality? Can we test that? So in the next slide, if we go, we'll come to see that how multifractality is helping us to understand the behavior pattern within a signal. So basically, you see here what we are doing, what is the meaning of the detrending. So basically, we are removing mean from the original data and we are taking the cumulative sum. So it is generating the random walk, basically, what we call the profile generation. And in the next step, now remember that we are segmenting the original n data set into ns part. S is the length of each segments where the order of movement is q. Okay. Now one thing you must remember that negative value of the order of moment will show you the small scale fluctuations, which will be very, very important, because in the next few slides we will come to see how the magic is being done by the small scale value of the q, order of exponent, order of moments. So basically then you see there are basic formulas of the computing of the fluctuation functions, but f q of s, okay, the fluctuations function of the q at order of moment is proportional to the scale to the power hq. Now we know that hq is the q at order Hasse exponent, which basically measures the value of the self similarity. Okay, and then we will generate the log plot. Okay, to check whether that particular data or whether that particular signal has the multifractality or not. So tau of q is your scaling exponent. So tau of q can be computed by q into hq minus 1 formula. Okay, derivative of tau of q will give you the singularity spectrum with value, alpha value. That is a very, very prominent thing in terms of judging the tissue surface heterogeneity. So we'll see how we are mapping these particular parameters as a feature extraction tool to explain the biological phenomena, because until or unless you can explain the biological phenomena, whatever the tools you may use, whatever the methodology you may use, that will become the obsolete. You may get certain result, but interpretation of the result is the most important thing. So you see, basically, in the ln fq of s and ln of s, if you see the plots, that the value of order of moment q 0 to +6, +2, +4, +6, and in the downwards -2, -4, -6. So the range of q order of moment is lying between -6 to +6, and you can see these lines are not parallel. So it does imply that there is a presence of multifactoriality, because there are multiple power law behavior. It exhibits the multiple power law behavior. If it is monofractal, then all those lines would have been parallel to each other. If not parallel, that is a significance that signify that there is a presence of multifractality. So in the next plot, you see the interesting thing. There are two. Remember that there are grades of cancer we are discussing. Grade 1 is the early stage and grade 3 is the final stage. Now grade 1 and grade 3 we are quantifying, for example, figure A and figure C. If you see, figure B is quite analogous to figure A, because scaling exponent is dependent on the Haas exponent. So if we consider the figure 1A, it will be good enough. So you see, when the higher order moment 0 to 10, there is not much differences between grade 1 and grade 3. But I told you in earlier slide that the negative value of qth order of moment will signify the small scale fluctuations. Now you see the negative value of q. In the negative value of the q section, if you look, there is a significant differences between grade 1 and grade 3. So what are the values you are observing here? In case of the grade 1, it is 0.53, and the grade 3 it is 0.44. What does it imply? Now we're quantifying the data, and we are now providing the interpretation. So what does it imply? We have mentioned that Haas exponent gives you the measurement of the correlation values. So your correlation value in the grade 1 it was 0.53, in grade 3 in the final stage of cancer it is reduced in 0.44. So what does it indicate? It indicates that when you persist towards the higher grades of cancer, your cell phenomena, the correlation behavior among the tissues will reduce. But from one particular sample, you can't make any judgment, but it is the indication. Okay. Now in figure C, if you look at the figure C, there is a singularity spectrum width. I told you that this singularity spectrum width gives you the information about the tissue surface heterogeneity. Now, why the tissue surface heterogeneity happened? That I told you earlier, that due to progress of the diseases in the submicron level, changes happen in our biological tissues, and due to and as a consequence of it, there is a phenomena like broken collagen fiber, so which actually rises your tissue surface heterogeneity. Now now why does the biopsy can't quantify them, or can't pick them up? Because that, as I told you, that the scaling range is very submicron level changes. Okay, so it changes in a submicron level scaling, so it is not possible to pick up them. It can be picked up by this kind of approaches, and that too with the negative value of order of moment, not the positive value of order of moment. Okay, so in the figure C, you can observe that singularity spectrum with plot. In grade 1, we are getting value 0.69, grade 3 0.89. Okay, sorry, extremely sorry. So it went ahead. The next slide. Oh, again buffering. So I am reloading it again. Hope it will work this time. Unfortunately, due to network issues, there are a lot of happening, and I have to re-uploading the PPT several times. So kindly have your patience. So it is uploading gradually. Yeah. Yes, sir.
Sir, in the meantime, my questions to you, sir. One questions.
Yes, yes. Please ask me.
Sir, actually, belongs to electrical, so I'm asking to you that in this current scenario, I have to use some machineries like transformer or generator, whatever. The condition monitoring systems we have learned actually just before 2 and 3 months. So it is related with a medical terminology. Here you told us that is some disease is already happened. Cancer, the cells is there, but is there any scope the predefined disease to some condition monitoring, like any disease cell or the blood flow relations like this?
Definitely, you see, as I told you, that these you have to condition monitoring. You have to identify the biomarker, right? So we are
Yes,
using
yes.
being the people under people from the engineering or physics background. We are more concentrating on the statistical biomarker. So that the tool methodology I am using and discussing here during the feature extraction purpose, that is the playing the role of the statistical biomarker. Okay, so we are predicting it in early stage. So that gradually I will come. It's a
Right,
fantastic question that I will gradually come. Huh? Thank you.
right, right,
Thanks for asking.
right.
Okay. So you see this figure C, you can observe that grade 1 case, the value is 0.69. In grade 3, it is 0.89. So we can see whenever we are going to higher grades of cancer, okay, the surface, it implies the surface heterogeneity increases because the broken collagen fiber phenomena becomes prominent there. Okay. So, so as I told you that from a single sample we can't make any justifications or can't come to any conclusion. So what we are doing, we are checking out the mean plus minus standard deviation value. So you can see that although in the Haas exponent section there is a decreasing trend, that it signifies that whenever you are going towards the highest grade of cancer, that there is a decrement in the correlation level, and because the width of the singularity spectrum, you can see the increment inclination towards the singularity spectrum. That implies that the more you will go to the higher grades, the more the surface heterogeneity will increase. But you can see there are certain level of overlapping. If you look at the standard deviation values, they are overlapping among the intermediate grades. So what does it imply? That although the phenomena is actually implying the actually matching with your physical phenomena by these by these MFDFA algorithms, but this is not the classifier, and that's the reason you require a strong classifier to classify them, because there are overlappings of the values. So it is playing a very strong indicator of the disease progress among the intermediate stages. We'll also see one of the cases with the healthy tissues as well. But MFDFA is a potential statistical biomarker, but not a classifier. So this is the mapping. This is the pathway what we are doing so far. So elastic scattering spectra from tissues we are extracting, then we are doing the Fourier domain inverse pre-processing, okay, subjected to MFDFA. Then we are mainly highlighting the two parameters. We are mainly spotting the two parameters. One is the Haas exponent, another one is the singularity strength of multifractality. So these two parameters we are looking after, where the Haas exponent is giving us the self-similarity measurement, whereas the strength of multifractality gives us the information about the tissue surface heterogeneity. So let's see. So this is the experimental setup. Okay, so xenon lamp is the source of the light. So you are shining the light is hitting towards your sample target. Okay, and few portion of the light will be absorbed by, as I told you, the protein lipid part of the sample, but there will be a certain amount of the backscattering spectra which will be recorded through the spectrometer. And as I told you that we are using the white light spectroscopy range 400 to 700 nanometer. You know that if we go beyond the 700 nanometer, that's the infrared red range. Even if you use the near infrared red range, that is also harmful to our human body. And if we go below the 400 nanometer range, that is the ultra UV ray range or ultraviolet ray range. That is also completely I mean that is also invasive to human body. So only non-invasive part is 400 to 700 nanometer. because if you have to tie up with the hospitals for the data collection, in vitro sample or in vivo sample collection, whatever you want to do, so you have to first of all convince the doctor that your whatever the tools or methodology you are using, that is completely non-invasive to human body, and then you have to sign the IRB protocol there. You are not expected to reveal the identity of any patients, so everything will be done in a anonymous way. So basically, this case initially, whenever we were approaching certain methodologies or tools, first of all we do the lab testing. So you know that whenever we are collecting the biological samples, we are preserving they may with certain sort of chemicals and in the lab. So that is called in vitro samples. So in first of all, once in the dark room experiment, optics experiment, once you get the success of this with the in vitro samples, then you come up with the in vivo samples, that is the live data. You can use the AI with your smartphone, and you can make the testing that, well, we are getting this success of the look, we are getting this percentage of the accuracy or something like that. So first of all, lab experiment success is very important, and our approach should be the in vitro samples, as I mentioned. So once we get the success on the in vitro samples, we went for the in vivo approach. Okay, so after the several trial of the in vitro approaches, we went for the in vivo. So first of all, definitely we captured the desired spectra information. Then we check that there is a multiple power law behavior, okay, from the Fourier preprocessing, from the Fourier spectra. So there is a chances of presence of the multifractality we can see. So sample preparation. So what are the sample preparation what we have followed? So biopsy cervical, for example, this is one of the example I have shared. So for example, biopsy cervical precancer tissue slices, the histopathologically characterized grade 1, grade 2, grade 3 precancer tissue. So histopathology, what does it imply? The term histopathology implies to monitor the tissue activities due to progress of the diseases. What kind of the changes may happen? So this monitoring of the changes in tissues with this, the main target is to predict it in early stage. Okay, so when the healthy to grade 1 phase, can you predict that? If you can predict that, you can easily cure cancer in early stage. So that's why we are taking so much talking about so much of the state of art algorithms and tools and methods. So these are the age range we have considered. So initially we have taken this amount of the samples. Okay, the standardized histological preparation of the is excised tissues involving fixation, dehydration. So in the dehydration step, we replace the water part of the but from the tissues with alcohol. Okay, cleaning with them. Okay, then embedding in wax. Embedding in wax is important to preserve the tissue samples for a longer period of range, and then sectioning under a rotary microtome with thickness of 5 micrometer. Okay, a lateral dimension. These are the always the precisions, because what are the precisions you are making when or what are the sample preparations you are making while making the in vitro testing. These are very important. So 4 millimeter by 6 millimeter is followed, performing subsequent dewaxing stage. So the consent, this is a very important line. The consent for the use of all intact tissues, human cervix with cancer and normal samples in our study was obtained from the ethical committee of the GSBM Hospital, Kanpur, India. Okay, so ethical committee approval. This is one of the examples that we have taken. We have collaborated with several hospitals, but this is one of the hospitals we have collaborated for the cervical cancer data sets. So ethical committee approval, until or unless ethical committee gives you the permission, you are not bound to, or you are not supposed to take those data sets. So once the ethical committee gives you the approval, okay, these guys are using non-invasive methods or technologies which are completely non-harmful to the human body, let's give them the permission or approval for proceeding towards the tests. Okay, the sample parameters method followed. Definitely there are certain guidelines will be there. Then the experimental system. In the experimental system, what type of the microscope you are using? We are using differential interference quantized microscope. This is one of the optimal in terms of the capturing the tissue sample pictures or the other informations. Obviously, another, for example, the spot size. Definitely the spot size information is one of the most important. What kind of diameter you are considering whenever you are talking about the infected lesions. So we are considering 1 millimeter. This is the state of our standard tools. So So mainly our concentration we have concentrated on 400 to 700 nanometer, but due to giving some relaxations on the lower limit to upper limit, we have taken 300, 360 to 800 on a rough side, roughly, but whenever we have made the in vivo testing, we strictly maintain the 400 to 700 nanometer range, because this 700 to 800 is the overlapping zone of near infrared range and white light, and 360 to 400 is the overlapping zone between UV and white light. In some cases, people consider that particular range, but when in vivo testing, we have not taken any kind of risks. We have completely restricted ourselves between 400 to 700 nanometer range. Okay, and the angle of the calibration spectral resolution was 2.05 nanometer, and the angle of the calibration was basically 150 degree, where we have found that we can able to capture the backscattered spectrum in our spectrometer in an optimum manner. So this is the further explanation of the experimental setup. So the lenses we have used, we know that collimating lens L1 has the job to, it basically makes your ray perfectly parallel. The ray what is being emitted from the light source, or the collimating lens make them a perfectly parallel. Then the basically the illuminating lens mainly collect those light emitted from the aperture and mainly focus them on the sample tissue samples. Okay, so mainly concentrates it on the tissue samples. Then the backscattered spectra is being collected by the lens L3 and L4, and then directly project them towards the spectrometer. Okay, so now you see we will investigate further investigations on the presence of the multifractality on the large number of the samples. So the particular sample we have considered here, as I told you, that ln fq of s and lns, this particular plot lns versus ln fq of s, this ls stands for the scale information, and fq this is the information about the fluctuations in the qth order moment, the fluctuation information. So you can see the value q value plus up to -4 range. So there is no parallel lines. Okay, so this indicates that this plot is the particular proof that the existence of the multifractality, because there is no parallel lines. If the 4 lines are parallel to each other, or the 5 lines are parallel to each other, there would be the existence of the monofractality. But in case the multifractality, due to small scale variations, there is no parallel lines. So in case of we have measured also the Hasse exponent value singularity spectrum width for the single sample. So we will observe the prominent, actually in our last case also, that we have seen there is a prominent changes in the negative value of the order of moment. Okay, we have seen there is a changes in the small scale fluctuation. So we have zoomed that particular area, and you can see that once the values goes down to negative 0 to 10, there is not much changes. But whenever you are going to 0 to -10 range, there is a deviation of the value in the fluctuation. There is a deviation value of the detrended part or fluctuation part in this particular from particular signal. So you see that the consistency of the multifractal trends, if we can observe the normal, now you see we have introduced the normal. Normal means healthy. Grade 1 and grade 2 are the early stages, and grade 3 is the final stage. So you see 0.63, the value reduced to 0.41. So we can see there is a decreasing trend for sure. That means reduction of the correlation level from the high correlation level to low correlation level. Hasse exponent value greater than 0.5 implies the highly correlated, less than 0.5 means anti-correlated. So once the disease progresses, there is a certain amount of the reduction in the correlation. Singularity spectrum width, what does it imply? It imply that 0.86 it has a increasing trend from healthy to grade 3 of the cancer. So we can see there is a change in the surface heterogeneity. That means the surface heterogeneity increases due to the prominence occurring of the broken collagen fiber in the tissues. So but the main concern is that there are overlapping factors in terms of the standard deviation values. So due to overlapping factors, your MFDFA methodologies or tool can't classify, but it can actually explain what is the physical phenomena is happening. It can a prime indicator, it can play a strong statistical biomarker role that from where you can pinpoint that from healthy to disease progress region. Okay, if you consider these two parameters, the reduction in the correlation level and enhancement in the tissue surface heterogeneity from normal to grade 1 is the indicator of the early stage disease progression. Okay, there is some abnormality thing is happening in your tissue, but to classify among the different grades of the tissues, so you have to deploy some sort of the machine learning algorithms. But multifactor dependent fluctuation analysis, which is being considered as the strong non-linear dynamics tools or methodologies, it can actually pinpoint the statistical biomarker on the disease progress section between normal to healthy to grade 1 and intermediate stages of the cancers. Okay, so again the display is gone. Okay, so I have to re-upload it again. So kindly hold on, please. I am re-uploading again. So it is uploading. So kindly have some patience. I can understand that due to some network issues, I have to upload the PPT several times. So it has been raining cats and dog outside, so we are facing some difficulty in network issues. So kindly do not mind. Please keep your patience. Okay. So this particular slide, okay, I have covered this, but okay. Just a second. This I already discussed. Okay, so we have seen that we require a particular classifier. Okay, so we will gradually discuss about deploying the classifiers. So in our case, we have the 75 samples of the classifier. So multi-color cross validation. So cross validation is important. So for examples, let me tell you one thing that if you have a whole sort of data sets, so data sets you have to split. So before splitting, you may do 3-fold cross validations or 10-fold cross validations. So if you, for example, if you have the data set samples of the data set sample size is 75. Now if you do the 3-fold cross validation, so in per section you will have the 25 samples. Okay, so in under the 25 samples of each section, what you do, you can use 70% of the sample for the training and validation purpose, 30% you can retain for the testing purpose. Okay, so once once you first of all you will check the testing accuracy, then you will training accuracy. Okay, once your validation is successful, then you go for the testing accuracy. Then what you can do from the each segment, after evaluating the part the cross each section of the performance of each segment part, then you can take the average of the accuracy, and you can present if it is reliable outcome. Okay, so what are the algorithmic flow structure in case of the deploying the support vector machine based algorithms? So we are basically clubbing the multifactoriality as a feature extraction tool with the support vector algorithms. Okay, so it's a MFDFA SVM based approach. Okay, so although the SVM is existing from 1997, there was a Vapnik has developed this particular tool. Even till 2010 and 11, it has a huge popularity. But later on, deep learning took place, and people went after that. But whenever you have the smaller number of the samples, this machine learning, in terms of the machine learning algorithms, SVM is a very strong and powerful algorithms, because there are optimal separating hyperplane is there, which basically considers when the points nearby the margin is given, weight 1, and if the farthest point which are assigned as 0, so these nearby points to a new under the margin is considered as the support vectors. So it has a very strong tool, but we have to see that how it is performing under the highly noisy system, because whenever we are considering the in vivo data, I told you that there is a huge amount of the interference of the stray lights. So whenever we are doing the dark room experiment in optics in the lab, you can remove some sort of the stray light interference because you are doing the experiment in a dark room. But whenever you are coming up with a mobile phone based solutions to check the oral cancer or skin cancer like stuffs in the open air, so there is a huge amount of the interference of the stray lights. So how under this noisy system you have to check that which kind of the algorithms are performing well. So we have tested with multiple machine learning algorithms and within the combination of MFDFA, but we found that these two combinations, MFDFA SVM and MFDFA, I will consider talk about another algorithm, MFDFA HMM, that means hidden Markov model. So these two algorithms are giving us the good results, but there are shortcomings in support vector machine in terms of detecting the early stage cancers, grade 1 and grade 2, because early stage pinpointing is our main target. That if we can judge the healthy to disease progress towards the grade 1 and grade 2, this to early stage, if we can judge them parallel in a satisfactory accuracy level, it can enhance the efficacy of the AI system in the healthcare domain. So what is our approach? So first of all, whenever we are building the testing data set or training data set, we are considering two information, two features, Haas exponent and singularity spectrum width. Okay, now we are putting them towards the training them with the SVM classifiers. We are making the threefold cross validation like I mentioned earlier. Then we are checking the testing of the algorithms with our testing data set. So basically you can observe that we are making here the multi-class classification, not binary class only, because healthy or disease it would have been the binary classification, but we are checking multi-class classification. That means normal, grade 1, grade 2, grade 3. Okay, so you are doing the multi-class classifications. Yeah, so now you see that what kind of the accuracy we are getting in terms of the healthy, in terms of the grade 1, in terms of the grade 2 and grade 3. So let's look at it. So I have, for understanding purpose, who are observing it, I have presented in this manner. Now look, if you look at the diagonally, so you will come to see about the accuracy level. So healthy case, okay, this 98.5, grade 1 57.14. Okay, so it has been rightly predicted as healthy 98.5, wrongly predicted 1.5% as the grade 1. Okay, it has rightly predicted 57.14% as grade 1, but wrongly predicted as healthy 14.29%, and wrongly predicted 28.5% as your grade 2. Okay, in case of the grade 2, we can see it, the grade 2 accurately predicted grade 2 as 55%, wrongly predicted as grade 1 35%, wrongly predicted as healthy 10%. Okay, in case of the grade 3, you can see 100% has made the prediction correct, whatever the samples we have in the terms of the 100%. But you see, healthy and grade 3, the accuracy level is satisfactory, but grade 1 and grade 2 is a very poor accuracy, 57.14 and 55%. So under the noisy system, we can see that our support vector machine, MFD, not only support vector machine, we should call it as MFDFA support SVM hybridized model. MFDFA SVM hybridized model, our proposed MFDFA SVM hybridized model is not performing as per the expectations. But although it has performed better than the other machine learning tools, but in this case, it is not performing well early stage, because like one of our eminent professor asks a very intelligent question, that what is the challenge in terms of detecting the early stage? So this is the challenge, and that is why it is not so easy. We have to try out with different type of the algorithms, to experiment with different type of algorithms, and then you can come to a conclusion that okay, this is giving a better result. Okay, so next we have tried out that to overcome these shortcomings, we have made a several trial and error method. So now we found that hidden Markov model. Let's see what is the what we can achieve with the hidden Markov model, because hidden Markov model is a dynamic Bayesian method. Okay, and we from people who have worked in the and with the dynamic Bayesian method, people from the mathematics statistics background or even the engineering background who have worked on that, they are quite aware that it is very effective in terms of the highly noisy system. Okay, so we took the help of the hidden Markov model. So hidden Markov model basically works in a conditional probability basis on the basis of the Bayes theorem. So there will be some information on the initial probability distribution, then initial state probability distribution, then transition state. So state-wise information. So why it is hidden Markov? Why the name is hidden is there because if X is a hidden state, from the information given in Y state, can you predict the state X? So that's why it is hidden Markov. Now we take the information like prior probability, posteriori probability. So prior probability is the current stage information. So at the end of the classification, you will take the help of the maximum likelihood classifier. On the maximum likelihood method, you will predict the possible outcome. But what happens when you go to the next stage? This is the posteriori probability information. So posteriori probability information is highly based on the prior probability information plus modification due to transition in the next step. So that's why there are several informations are given. So one of the real life example is Monday was a sunny day, Tuesday was a rainy day, Wednesday was a cloudy day. So what will be the condition on the Thursday? So on the basis of these three state informations, you have to compute the probability of the Thursday. Okay, so in this way hidden Markov model works. So we have also use the same parameters, feature extraction parameters. So Haas exponent, singularity spectrum width, we have built the training data set. We have then what we did, we have made the training of the hidden Markov model. Then we have tested it, and according to the maximum likelihood classifier outcome, we have made the judgment of the multi-class classifications. Remember, multi-class classification is not very easy. Okay, because binary classification you can get the higher accuracy, but there we were only judging healthy and disease. If in case of support vector machine, whatever the accuracy we achieve, for example, you see grade 3 we got 100%, but grade 1 and grade 2 hampered. Grade 1 and grade 2 hampered. So if we merge them as a single class, then the accuracy level would have increased much. But in that case, you were not able to predict the early stage progress of the disease, and which is the main challenge and major challenge in our real world scenario. So we are sitting to give some impactful solutions towards the society. So there is no there cannot be any kind of shortcut. There cannot be any kind of we can't proceed. We can't afford any kind of shortcut methodology. We have to be diligent enough to check in a smart way that how can we can achieve. Okay, this algorithm fails. Okay, this combination fails. So let's try out the next thing. So after doing the several amount of the trials, we have found that okay, so this is the same way of representation. You see, healthy it is predicting 100% in case of the grade 1. It is predicting correctly grade 1 as 85.45%, while wrongly predicting grade 1 as grade 2 14.54%. In case of the grade 2, it is predicting grade 2 correctly 78.57%. It is predicting wrongly as grade 1 21.43%. It is predicting grade 3 correctly as 100%. Okay, so normal grade 1, grade 2, grade 3, you can see, you can look that grade 1 and grade 3, or I mean normal and grade 3, it was earlier, it was also good. Here it was also superb. But grade 1 and grade 2, which are the main challenge to detect the early stage cancer, we have made a significant improvement from 55, 57 to 85, or nearby 80 percentage accuracy. So now it is quite acceptable range, because early stage, due to very submicron level changes, very difficult to quantify them, and it also got mystified because of the huge amount of the stray lights. Because see, we are doing it on the in vivo data, not the in vitro data on the dark room experiment samples. we are doing it on in vivo data, and in vivo data, as I told, huge amount of the challenges of the cleaning and pre-processing. So you can't, and we are from engineering background people, we all know that we can't remove noise 100%. So there will be always some unwanted signal interferences. We can reduce the possibility of noise interfering. We can do background extractions, we can do normalizations, followed by for example Fourier pre-processing. You can bring them in the Fourier domain. You can remove the noise, because that will become in the multiplicative format, as we discussed, because in spatial domain noise and signal is in a convoluted format, but in frequency domain it is in a multiplicative format. So you can see we require the knowledge whenever we are working in the healthcare domain. We require the knowledge of signal processing, image processing, computer vision. We require the knowledge of optics, especially biophotonics. We require the knowledge of machine learning, deep learning, whatever we may call. So basics are always important. We are starting from the basics, from the second year, third year study of engineering, signal processing. Then we are going to image processing, then computer vision. Then we are using biophotonics or optics in general, and then we are going to AI, machine learning, deep learning. So wherever you may apply the high level of methods, if your pre-processing step is not correct, you will not get the success. So basics are always important. Linear algebra to signal processing, everywhere we have to give the emphasis. We have to check the basics, because those essence will definitely come to play in the significant role whenever you are dealing with real world data, because this is the real world data. This is not any kind of synthetic data we are dealing with. So real world data noise will come, and it is very challenging task to get even the 80% accuracy under this huge noisy system. So we have seen that how using the hidden Markov model we comparatively achieve the better result. And we remember that we have, as a representational basis, we have shown these two examples. But don't consider that we have only tried out with these two hybridized model. We have tried out several ample amount of the models, because we have shown you just two models, that these two are giving us the optimum result. But HMM is the best in terms of dealing with the noisy system, Bayesian models. All of you who are working with the highly noisy system, I would request you to try it out, hidden Markov model or any kind of the dynamic Bayesian model. You will get definitely a fantastic result. So now one thing we will deal with, for example, we have seen that cancer is one of the life-threatening disease. Now optical coherence tomography image we are taking of the human retina, here we'll be judging the diabetic macular edema. So this particular research project we have collaborated with LB Prasad Eye Institute Hyderabad. Dr. Jay Chabrani, one of the eminent ophthalmologists, now he has shifted to US. So somehow anyway, so this is also the major reason of the blindness. So remember that we are considering the chronic diseases, life-threatening diseases, vision loss, because diabetic retinopathy, diabetic macular edema is one of the reason, along with the diabetic retinopathy, for the vision loss. So that's why we have also took this particular challenging problem. So what we have done, we have OCT can extract depth resolve index in variations, acquired in vivo retinal OCT. So we are also capturing the in vivo data here. Then crop different layers of retina, then extracted depth resolve optical index variations of different layers. Then we have analyzed via MFDFA to extract alteration of multifactoriality due to progress of diabetic macular edema and an age-related macular degeneracy. Because after the age of 50, some people have the diabetics, so they suffer for the vision loss due to diabetic macular edema. Okay, so that's why we call it also age-related macular degeneration, AMD. Abbreviated from, we write it AMD, age-related macular degeneration, or diabetic macular edema, we call it as DME in abbreviated format. So you see there are different retinal layer informations are given, and you see we have how we have mapped them. And now we will check that we have also done the Z-axis scanning. You can see OPL layer far from DME and OPL at the edge of DME. We have also checked the Z-axis scan, and then we have checked that what is the activity. We have chosen one layer because there are multiple amount of the layer. So as a representative layer, we have considered OPL layer, or outer plexiform layer. The full form is outer plexiform layer. So you can see the Z-axis scan result far from DME and at the edge of DME. So this is the dynamics you can observe. Okay, now we will see that we will apply multifactorial dependent fluctuation analysis here also MFDFA as a statistical biomarker as well as feature extractor. So what is happening now? We will see. Look, so we are considering as I told you, that outer plexiform layer. And now you see this order of moment we are considering here +4 to -4. So we'll first test the presence of the multifactoriality. So here you see these lines are not parallel to each other. So as I told, if they're parallel, then monofactal, but due to low scale variations, it will not be parallel. So there will be certain shift. So this is not parallel at all. So now we are going for measurement. There are presence of multifactoriality. That means H equals to, then we will see that Hus exponent plot in figure A and figure B is the singularity spectrum with plot. So here remember that in earlier case we have done multi-class classification. Here we are doing binary classification, either healthy or the DMA affected layer. So we see that in case of healthy OPL, you observe that the H Hus exponent value is 0.61, DMA affected OPL, you see the value is 0.52. Okay, so again there is a reduction in the correlation level. When we are proceeding from the healthy to diseased tissues, there is a reduction in the correlation level. Here you see healthy OPL layer, sigma value is 0.58. Whenever you are going to DMA affected layer, the value is 0.94. That means the tissue surface heterogeneity is increasing. You can see the tissue surface heterogeneity increasing like the earlier cases. Okay, because what is happening due to progress of the diabetic macular edema in the retinal layer, there is what is happening in the submicron level, broken collagen fiber is there. Now healthy to disease, whenever you are progressing from healthy to disease, the broken collagen fiber phenomena is becoming more prominent. So surface heterogeneity increases. So what is happening that at q quadratic order of moment, h equals to q2 in OPL of diabetic macular edema indicates the reduction of the optical index correlation in progress of DME in the from figure A, and from figure B, the increment in the sigma value, it implies that in OPL of diabetic macular edema, DME indicates the increase of the strength of multifactoriality or the heterogeneity in layer due to progress of the DME, heterogeneity tissue surface heterogeneity. Okay, so now what we are doing in the same manner, we are representing them mean plus minus standard deviation values for layers like choroid, ONL, OPL, IPL, GCL, NFL layers. So from healthy and AMD stands for age-related macular degeneration. So we are also focusing for the geriatric care purpose, we focusing over 50 years age, because over 50 years age, due if somebody suffering from diabetes, it becomes if the diabetic macular edema is becomes a major range for vision loss. So we call it as age-related macular degeneration in the medical terminology. So you see in HQ equals to 2, you see there is a decrement healthy if you compare between healthy and age-related macular degeneration, there is a decrement between the correlation level in every cases. You observe here, you see healthy and AMD, you can see there is an increment level of the surface heterogeneity in the sigma value. If you consider layer NFL healthy, NFL AMD, NFL GCL healthy, GCL AMD, sorry, extremely sorry, GCL healthy, GCL AMD. So in this way we can see, so we can conclude that implies the decrement in Hus exponent in Q equals to 2 implies that overall reduction in the depth correlation in of refractive index, but increment in the tissue surface heterogeneity. Okay, but here you see there are also overlapping. I mean, there are also standard deviation values, but there is no overlapping. Unlike the earlier examples, several examples in the cancer domain, in eye disease like diabetic macular edema, there is no overlapping. But why? Because the number of sample is very less. We are experimenting with a number of samples which are very less. So under the lesser number of samples, this feature extraction or statistical biomarker like MFDFA can classify also. You do not require now to deploy machine learning algorithms because already it is classifying. But whenever you increase the number of the samples, there will be definitely overlapping, and you have to apply machine learning algorithms. But these nonlinear dynamics tools, I have given you both the examples. One, the nonlinear dynamics tool is not adequate enough to classify. You require machine learning algorithms to classify them. And another example, there is a due to lesser number of the samples, nonlinear dynamics tool itself can classify. You do not require machine learning algorithms, but these are not the classifier. Coincidentally, it is classifying, but these are not the classifier. Because it has classified, we do not require any kind of algorithms, statistical classifiers, but this is a very significant tool. What you can rely on MFDFA if you are dealing with a biological tissue based imaging or spectroscopy approaches. You can do the feature extractions, you can generate check you can pinpoint the progress of the diseases from early stage, healthy to disease progress, early stage basis pinpointing. It is fantastic, significant. But remember, for the large number of the samples, if you want to do the classification, then what you have to do, you have to take 2 or 3 MFDFA parameters like we have done here. You have to club them with different machine learning algorithms, and then you can get the I should not use that term magic, because this is not a magic, this is a hard research work. So you can see the possible outcome. Okay, so these are the few relevant publications to this domain. Okay, the result I have presented here in the slides are taken from these are my publications. Okay, and now we will see, we already have covered the science technology part. Now we have, first of all, we have discussed philosophy, then we discuss science, then we discuss technology. Okay, now we are discussing on the product. Like I told you, the flow is philosophy, science, technology, product, and marketing. These are the 5 sets together once you are launching something to create impact on bottom of pyramid. So what are the solutions you are providing? So impact on BOP level, bottom of pyramid level. Pain-free early stage cancer diagnosis and low-cost portable device. Generate reports within a few minutes, where biopsy requires the several week times to come up with the report. Look how we are matching the problem canvas and solution canvas, what we discussed during the initiation of our talk, philosophy development, that this is our solution canvas, this is our problem canvas, this solution we will provide to overcome them. And you see, with our science and technological development, how we are overcoming them. In the final stage, automatic solution and highly efficient. So this is the app looks like. Okay, in the spectroscopic app. So the app it is a cloud analytics based app. We are also now developing the edge analytics based app as well. As I told you, that we are dealing with a very tricky algorithms. For example, how we can apply linear algebra in the reduction of the time complexity level. So we have talked about the nested for loop where the order of complexity was n square. We have vectorized them, we have unfolded them. So we are directly, instead of processing 2D images, we have unfolded them. So unfolding, as per the theory of nonlinear dynamics, unfolding 2D to 1D, first of all, gives you the more hidden features information, and secondly, in computational manner, it reduces of the time complexity from order of n squared to n, and it is required whenever we are dealing with a low processor devices like mobile phone. So if I get the opportunity in sometime in near future, I will discuss about our progress of the edge analytics, how we are dealing with this tricky time complexity algorithms, and we are coming up with some amazing results in terms of the edge computing based approach in the healthcare domain. So now, like you remember that I have skipped their unique selling proposition. I told you that we will gradually discuss during when we will come here. Now you see. So in terms of the selling purpose, selling point of view or marketing point of view, you have to highlight that what are the key features you are providing where your competitors are not. So basically replacing painful and cost-effective biopsy, 100 times cheaper than biopsy, accuracy greater than 95%, portable, lightweight, and 80 times faster than the biopsy. So in this way, one should present their product features. Then obviously business model, like I have told you that we will discuss about the revenue model during the marketing section, product and marketing section. So you see, scan, even if you charge 100 rupees per scan, if doctor charges 100 rupees per scan, still it is 100 times cheaper than biopsy. Or you can still sell the device once at a time in a hospital. So there will be no further cost will be associated with that. But this charging of these scan basis charge is called software as a service. People who are aware of the cloud computing, they know software as a service, infrastructure as a service, or platform as a service. So we are using it as a software as a service. As I told you that softwares are the new hardwares, as per the philosophy of MIT in 2016, to reduce the cost, product development cost in third world countries, developing countries. So being the people from the third world country, we have 96% people under the bottom of pyramid category. Can we create impact with our low cost solution on them? Can we bring the smile to their face, whatever the limited capacity we have? That is an humble effort on this particular domain. So growth strategies, So these are the growth strategies. You know that you require samples to build a strong data set. So ongoing clinical trials in hospitals. You can obviously, you have to, as doctors are the ultimate decision makers. I told you that in healthcare domain, doctors are the ultimate decision makers. They have done 5 to 6 year studies in MBBS. They understand the cell biology pretty well, and cancer biology varies people to people. So even if your app is showing that these people do not have cancer, but doctor can understand from their sixth sense that even if that particular people may not have cancer, but there may be some other abnormality which is going on, and it may develop in next 5 to 10 years to a cancerous stage. So that's why doctors influence is very important, and these that's why these products are available for a selected hospitals. Okay, and it is not available for a normal human being, because this is a very serious issue. This is not about measuring the blood pressure or something like that. So this is a very serious issue, and doctors can only judge that whether that particular people is okay with this particular app-based approach, or they have to do certain sort of the biopsy, or they have to take certain sort of the medicines. So that's why doctors monitoring is very important. But this is a very strong catalyst to making the cost reduction and increasing the precision AI-based approach I'm talking about. So you can do the 50/50 revenue model sharing with doctor. So whatever maybe, I mean, it depends upon your dealings with doctor. So the competitive landscape. So this is one of the, what is the unique value you are adding in the market. So that I also told you, we will discuss during the product and marketing section. So in terms of the low cost, accuracy, smart device, data driven, cloud based approach, we are superior than our competitors in all kind of the aspects. So we are the first research group across the globe who have explored MFDF in terms of the retinal disease predictions. So our appreciations as our research success has been appreciated by televisions like G News, Odisha TV News, All India Newsx, also the global news site like Yahoo News, Nature India. Also, we are featured in the leading newspapers like The Hindu, Business Standard, Indian Express, Economic Times. In cancer research success also has been featured in the leading newspapers like The Hindu, Business Standard, Indian Express, Analytics India Magazine, and Nature India, as well as our cancer research success has been included in the syllabus of India's most toughest and leading exam, leading competitive exam, IBPS, IAS, UPSC, as well as banking exams. So we are the first runner-up of the MIT NASA hackathon as a global award, which took place in 2017 with this particular innovation. And definitely what we are now currently doing, you see the digital world is getting double. We have the exponential growth in the databases. So we know by 2035, according to the experts, whatever the processor power we have, even the supercomputer will fail to analyze this bulk amount of the data. And that's why we are proceeding towards the quantum computations using the entanglement property of the quantum phenomena. So now our challenge, what we are doing, we are mapping our classical algorithms towards the quantum machine learning algorithms in the healthcare domain. So we have already reported one paper in IEEE. Let's see what the fate of it. So basically now our main focus is to edge-based approach one, and the second one is the quantum, deploying quantum machine learning, keeping the future in mind, because it's not only about the accuracy, as I told you, it's also about the time complexity, and quantum algorithm works exponentially faster than the classical algorithm. So and apart from that there is a limitations of the processor power. So how can we remove that limitations with the quantum computers? So that is another major challenge. So we are also putting our step towards that as a visionary steps towards that. So gradually I will keep on updated you about our progress. So whatever we are making, whenever the next opportunity will come up. So it is again stop presenter. So 2 or 3 slides are remaining. I am re-uploading it again. So kindly have some patience. So it is uploading. So only 2 or 3 slides are remaining. So kindly have some patience, please. So I hope, I guess I have 10, 11 times already uploaded the slides, re-uploaded the slides. So I myself also have some patience. It's really a testing of patience as an individual basis. Okay, so it has appeared, but it's gone. The screen appeared, then where it is gone. So here, sir, only 2-3 slides are remaining. Is it okay? I think already we have passed. It is 3:40. So will that be any problem if we hold on for 5 minutes? I am re-uploading it again, but there is some difficulties going on. Hello, Hilok sir, can you hear me?
No, as you wish, you can continue.
Okay, only 2-3 slides are remaining. So almost we are done. So that's why.
You can continue, no problem. But it's not displaying.
Okay, thank you. It is not coming, so I am re-uploading it again. So already as today 12, 13 times I have already re-uploaded
Yes,
several
yes.
intervals. Anyway, and some network error is going on, unfortunately.
That is not in our hands, so we cannot do anything.
Exactly. Okay, so it finally has appeared. So at the end of the day, I want to ask a very funny question. So we have already discussed about the explorations of signal processing, computer vision, machine learning, AI in the healthcare domain. So we have covered all the serious stuff. We have discussed that how we should develop philosophy, how we should take the help of science, technology, product, and marketing. So these are all the very serious stuff. Now, at the end of the talk, after the whole days of lecture, you are already bombarded with whole days of lecture, and you all are very tired. So, due to lighter note, I want to ask a very funny question. There is no science and technology behind that. If any one of you kindly volunteer to answer it, please continue. So the question is, what is the difference between a computer vision scientist and a film director? What is the difference between a computer vision scientist and a film director? This is a very funny question. There is no science and technology behind that. To wrap up my talk, I want to talk it in a lighter note because people are very much tense due to this pandemic scenario are going on, and I want all of you please stay safe and healthy. But can anyone want to answer this on a lighter note? What is the difference between a computer vision scientist and a film director? Is that just a funny angle of it? Anybody want to try it out? Okay, so
No,
let me tell you. Please, sir, carry on. Please, sir, carry on.
no problem.
Okay. So let me tell it. Film director says light, camera, action, right? So computer vision scientists say light, camera, pixel. So that's a funny difference. And also we have talked about our ongoing studies and all. So basically we are exploring gradually in the quantum machine learning domain also. as I told, we can overcome the processor limitations. And second one is the quantum algorithm works exponentially faster than the equivalent classical algorithms. Okay, definitely. So you can join me on the social media. These are my social media handles. If you have any query in future regarding deploying AI, machine learning, deep learning, or any other things regarding any support from the multifactorial dependent fluctuation analysis or any collaborative research work, I am free to collaborate. So thank you very much. Thank you very much for your kind patience. Because there are so much due to technical difficulties, there are so much interventions has happened. But thank you very much for staying till the end, and I am thankful to Hirok sir and Deepak Kumar Mondal sir. They are my respected teachers when I studied my BTech in Kolaghat Engineering College. So those teachers are very generous enough to guide us towards the research directions, the benefit we got from the Kolaghat Engineering College. That I want to highlight that to build the research mindset up right from the beginning, from our BTech days. These teachers were phenomenal. From whenever I went to any teachers, whether it is EC department or any other department, computer science, mechanical engineering, any department, I would say they all was very kind enough to provide their extended support to explain the complex phenomena of engineerings. And definitely most of them I try to keep in touch with my professors, and most of them are in keep in touch with me. And it's a fantastic experience. I miss those days from 2008 to 2012. This 4 years was amazing days in my life. And when I moved to ISAR for doing my masters, I carried out those essence, because these strong foundations of signal processing, image processing. I remember that during our final year, I took image processing as an elective subject. I am thankful to Professor Soiwal Pradhan, who are the HOD then. He has given me the permissions that suppose you are working in this research field, you can take this subject as an elective, because not much students were curious to take that subject. And you see, because of those guidance, because of those blessings, we are nowadays we are being able to deploy those things in a higher level of the research problems. And Hirok Maithi sir was our instructor in that time. Sori Sanal sir was also there as an instructor of those particular subjects. So it's not possible to take everyone's name. I am thankful to Professor Sukanto Samanto, Professor Bhattacharya, because I got the opportunity to present here. So I took few names, but I am thankful to each and everyone, wholeheartedly, because it is your blessings that we have proceeded towards some extent in the research directions. And I am really feel proud as an alumni of CMK. Thank you very much. Thanks a lot for inviting me here, and keep on blessing me. Thanks a lot. Thank you.
Thank you, Sabyasachi. DKM sir.
Thank you.
I'm here
Yes,
also.
sir. Thank you. Yes, sir.
If any participants have any question, please.
If any participants have any question, you can ask. Thank you, Shobhashachi, your whatever you have given the information. I have one question.
Yes.
The question is that the macular disease which you just have defined, which you have just said that you have done work taking the data from diabetes patients. But does this disease comes in the normal people? That means those who are not having diabetes.
Chances are very less. It is more prominent towards people who have the diabetes more than 55 age. That's why we have concentrated on the geriatric care section. We are considering the patients for more than 50 age, because that is the most prominent zone where people have chances of vision loss due to diabetes. But macular edema can happen in any ages, but chances are very lesser chance. It mainly happens towards the little bit of older people who has the diabetes. So that's why the name is diabetic macular edema. But in general, macular edema can happen, but chances are very less.
Why I have asked this question, because I know a person. He's from our college only, so he doesn't have a diabetes, but he has this problem. So he's still having the treatment.
Definitely, this macular edema retinopathy may come up, but chances are very less. Very few people. I mean, if you consider the probability density of suffering of the diabetic zone, I mean, people who are suffering from diabetic after post 50 years age, and the rest of the people, the chances are very less. Unfortunately, it may occur, but chances are pretty less.
Okay, okay. The data actually you have done with respect to diabetes.
Our collaboration with yes, our collaboration was done with LB Prasad Eye Institute. So the patient's region we have taken is the age limit, age range is from 50 to 65. This age range we have considered the data, and we have developed the algorithm, because this is the most prominent, section. If you, as I told you, if you see the probability density graph of affected people in comparison to this age range with the rest of the in the younger age case, there are very lesser chance. People get affected, but the chance probability is very lesser. And that's why doctors has told us to focus on this particular area.
Thank you.
Most welcome, ma'am. Most welcome. Thank you. Thanks for asking the question.
So I think